accommodating here. This is an old presentation here, but I want to just go through it real quick. This is the kind of stuff we're trying to avoid. This is what we're going to talk about today. And this is what I've spent a lot of my career going to try to avoid here. And we call this vertical mulch on walls here. And it has a place in horizontal circumstances, but we don't want to see it vertically on buildings. And so we make it easy at Vapor Shield to do this type of thing. And we have a little mock-up back there on mass timber, which is something that we've been very involved with for a long time. And this is just kind of a preamble that I'm going through. This was an interesting project in New York. It went through Superstorm Sandy, if any of you remember that. This was right on the coast of Long Island. It was a high school, and it was exposed for almost 2 years with just the membrane and the cladding attachments, and it had 0 leaks, so it was a great test. And in fact, they used this building, the Army Corps, to handle a lot of the repairs afterwards in the region. And we're very committed to sustainability. This is, of course, my role in the company, but it's a very broad umbrella. Again, hence the mass timber. That's where it's involved with here. And we look at ourselves as just an evolution in technology. And we're always pushing the envelope, no pun intended, trying to develop better systems and solutions for the industry. And that's what we've been doing from the beginning. We've been involved in ILFI and Mindful Materials and other organizations where we've pledged for transparency and to eliminate harsh chemicals. And so we're always collaborating with other manufacturers and architects in the industry. And it's a great privilege of one of my, and I'm going to kind of go through this really quickly, my kids here helping each other up the tree. And this is exactly the kind of disposition that I like to help cultivate, because sometimes things can get stressful when costs increase. And when we're doing difficult projects like this roof line here in Atlanta on the first mass timber CLT project back in 2017 with Jennifer Bonner. And this is out on Block Island. And this is just a week or two ago on Signal Mountain. And so this is one of my favorite things that I get to do, is these types of collaboration. This is at Grace Farms up in Connecticut, just outside of New York, where I was on a summit at a summit with the State Department, trying to eliminate forced labor from supply chains. So all the way from the job site to these sort of government organizations, we try to stay very involved. And we also get into the details, and we'll talk about this. And I'm going to switch over to this other presentation here. Bear with me. Okay. Oops. There we go. Okay. I'm doing a little bit of bait and switch on you guys because I put part 3 of the presentation, but this is actually going to be a hybridization of 2. It's really a 2.5. This is a 3-part series. And here's my contact info. If any of you have any questions afterwards, I'm pretty easy to get a hold of. Pretty easy to find. So I'm local here, but I cover North and South America and New Zealand. So I have a pretty far reach globally for sustainability with the company. That's where we are. And this is going to be a fun presentation, just a fun talk about thinking about existing buildings. And I also added in some images from some local projects. And if you see anything that might be one of your projects, don't worry about it. I'm pointing out some things that I hope that we can improve, and we're going to do that more as this coming year goes on. But let's talk briefly about net zero. So net zero is a pursuit that can be related to carbon, but it also originally or oftentimes was energy, in fact, but it is a buzzword, and so it's helpful to define them. And we can even define buzzword here, but it's net zero, if you look it up in Webster, resulting in neither a surplus nor a deficit of something. And it goes straight to carbon, interestingly enough. And the first part of this presentation, the first one in the series, is about carbon. But I just want to introduce you to the concept of net zero if you haven't heard about it, but there's some complexity to it. And if you're familiar with the next gen homes in just on North Shore area that we did with Green Spaces several years ago, that was a really fun collaborative project. And I'm going to talk about that as an example here in a little bit. It's funny that Webster says by 2020, all new homes, as a quote from, I'm not sure who Kaufman is. If anybody knows, let me know. I don't think they quite achieved that, but I think we here in Chattanooga might be even a little bit ahead in some ways, as we're about to show. So when we talk about net zero energy, there's complexity to it. And I'm not going to get into that today because I want to focus more on local stuff, but I just want you to understand that you have to understand what primary energy has to do with it. So just kind of put that in your back pocket, and then understand there's a lot of different ways of looking at net zero depending on which organization you're certifying through, or if you're certifying at all. I didn't certify when I put solar on my home, and I achieved about 98% of net zero, so I wouldn't have hit these certifications. But I'm fairly happy with what we did. In fact, use Phoenix City Solar as well. So there are multiple definitions. This is actually how the government defines net zero. The federal government, U.S. federal government, EU does it a little bit differently, and I'm going to show that in a moment. But it's essentially balancing the energy needs. But it also goes straight to zero emission, goes to renewable sources as a preferred means, or sometimes necessary for government projects. So again, different ways of looking at it, but also very good pursuits. So we want to produce enough energy to offset any energy consumed, is in a nutshell what we're doing with net zero. So let's look at a few project examples. This was one of the first this was the first fully certified Living Building Challenge project in upstate New York, the Omega Center. And it took you first of all, of course, take care of the building envelope to reduce the loads. You'll hear supply and demand a lot when you think about how it works for net zero. So it had a fairly massive solar array, similar to, I think, the third certified project, the Bullitt Center in Seattle. When I was out there, I was living there at the time, and had just started at Vapor Shield. And that one has a huge canopy that extends out onto the street, actually, to accommodate all the solar, because it's an urban office building. And there's a lot of different ways of looking at it. A lot of times it's going to be, I'm going to mute that. A lot of times it's going to be higher end projects like this, but there are some incentives out there, and Green Spaces does a good job helping with that. And hopefully we'll see some more of that as well to make it a little bit easier and more in reach for people. And I think that's what was so great about the next gen homes, is they were a market rate. How many of you are familiar with the next gen projects? Okay, cool. Okay, I'm really glad I'm bringing it up then, because it's a minority of you in here who are familiar with it. This was a fantastic project to participate in. Green Spaces submitted for a grant to document and to demonstrate that you could build market rate urban infill single family residential, 3-bedroom, 2-bath, 1,800 square foot homes, and sell them for market rate, but they would be net zero. Build them at and produce a profit. Because in order for things to be sustainable, ultimately, it has to be economically sustainable as well. So we had to keep that in mind. And this was a really just a fantastic project to be a part of. And here's this time lapse, I believe, is on the Green Spaces website, so I'm going to skip over it. But there's also a case study on the website as well that I highly encourage you to take a look at. Yeah.
You might mention where it is.
It's about 2 miles that way. It's right on the opposite end of downtown, right over North Shore.
North Market.
Yep, right up North Market. Thank you. And here's you can see kind of the ridge in the background there. And these are the 4 homes. The first one was built and then was refined afterwards. And yeah, it was a great project. And as far as, demonstrating the feasibility of it, that's what's so groundbreaking about the next gen homes. And so that's a great project example. And I believe they have been net zero every year. And I think that's documented on the website. So the next thing we're going to talk about briefly is deep energy retrofits. And deep energy retrofits are something that, and I'm going to go very quickly over it, but it's existing building stock and taking them and adapting them. And when you think about deep energy retrofits, you don't hear these as much anymore, but I've started to hear the term come back up. It actually, I think, originated in EU, and they define it as at least a 50% from pre-renovation baseline improvement in energy using or reduction in energy usage. And so again, this supply and demand, and essentially my career has mostly been on the demand side of things, where we're reducing the energy load required in buildings, and whether it be new buildings or existing buildings. So again, with deep energy retrofits, you're taking this existing building stock and you're optimizing the building envelope, your air sealing, a lot like what you guys are doing in Building Green and in the community around here as well, but just on typically a larger scale with deep energy retrofits. And you're adding, but one of the things that happens when you add all this insulation, you upgrade windows, et cetera, you air seal, you actually reduce the drying rate, the natural drying rate of the building. And so we want to take a look at how this might look on some actual buildings, because building envelopes can get fairly complex, like this one here that has thermally broken Z attachments, fiberglass Zs running horizontally with exterior insulation over gypsum and metal studs with cavity insulation as well, and 2 layers of air and water barrier systems. So this project in Boston, Massachusetts, lovely building, lovely rendering. And but I love this exploded view here showing the added air barrier system to the roughly R0 wall assembly and adding on about R40 to it in continuous exterior insulation, and then adding a U value of 0.2 to windows fenestration across this residential building as well. But when you do this, you really have to consider how that changes the hydrothermal performance of the building, which is the way that the moisture and heat moves through the building. And so there's a few different ways you can look at this. I think it's funny that it calls it R3 as far as the brick assembly goes, and that's probably just because of the air gap back there. But the entire thing is essentially a thermal bridge, this whole building, kind of like this one. So it's there's a lot of energy loss that happens. And we're going to talk about historic preservation as well and how that plays into this conversation. But you really have to understand this. So WUFI is a German software that's a way to model how moisture and heat move through the assembly. It's fairly complicated and it's garbage in, garbage out, like any other modeling system. It helps to have some experience into how buildings work in different climates. And but this can be a helpful tool, and it can be dynamic as well. But it takes assembly from the interior to exterior and shows that moisture gradient and how that's going to change. So you may have heard of dew point before. That word is somewhat of an anachronism these days because of more sophisticated evaluations or modelings like WUFI, because the dew point is always changing in an assembly. And when you're air sealing, well, dew point becomes much less of an issue interstitially. All right, I'll get past this technical stuff pretty soon. Don't worry. Here's an example of a project that had a deep energy retrofit. It's up in Bennington College. That ladder right there, I think, was the most wobbly ladder I've ever crawled up on a job site. But beautiful craftsmanship, copper sill pans and flashing slate roof. And what they did is they did a 2-pound polyurethane spray foam to the interior, which means that you have to add in some drying potential to the exterior because you all of a sudden lost that. So all that foam is great for energy, but terrible for moisture and drying potential. And so you really have to maximize that drying potential. And they did a good job by putting permeable roofing underlayments like this one here on that exterior existing, and then giving a ventilated, they actually added ventilation with a extruded batten counterbatten system underneath the slate roof up there as well. So this is a good example of how the right way to do a deep energy retrofit. And then here on the next gen homes, as you see here, they actually took the offcuts of siding and made a rain screen system. And this is another way to enhance the drying potential. And it really should be required on any commercial building and residential in this climate as well. And in other mixed humid climates, it's the right way to build. So when we think about net zero, I'd really like us to take a look at and think about net zero moisture as well. So don't just think about the energy, but think about the moisture loading of the building as well. And I like to look at it that way because if you remember the definition of net zero from earlier, it's neither a surplus nor a deficit of something. And essentially, we want to have a deficit in moisture. We want to have as much moisture, if not more, as possible. We want to build in a buffering capacity, which masonry has built in. So there's something called hygric buffering, where if you throw a bucket of water on the outside of this wall, it's not really gonna, and you keep on doing it for a while, it's gonna take quite a while for that water to migrate its way to the interior. It's a barrier type system, but it has this buffering capacity for both ambient moisture, which can cause issues in the summertime. And so you have to have air conditioning in this climate for that reason, for comfort, for the latent loads. But it has a lot of capacity to hold moisture and release it. It buffers. Wood framing has about 1/10 the buffering capacity of a masonry structure. Metal studs have about 1/10 of what wood has. So you're talking about 100 times more buffering capacity in these old buildings to handle moisture. So you have an advantage there in some of the old buildings than you do in some of the ways we build today. Yes.
Why is that good?
That is good because it allows, it's good for some things. It's good for moisture because it can handle a lot more absorption, right? So if you go on a job site, for example, after a rainstorm on a commercial building with metal studs, you'll find water in the tracks, and it just doesn't. There's nothing to absorb it and release that over time. So it's just a capacity to handle that moisture. We handle it on modern buildings with rain screen systems. That's the right way to do that. But they need them a whole lot more than the older buildings do. But you really need them on the older buildings when you start adding in these energy efficiency improvements. So the rain screen system is the way to handle this regardless. And on that mock-up back there, it shows vertical battens and cladding that shows drainage back there. And we used to have little paper raindrops that I cut out. I don't know if they're still back there, but the idea is it shows just what's showing here, where this, whoever built this on SketchUp, I don't think had much building experience because they didn't lap their lap siding. But you know what? That's okay with the rain screen system. We can get away with those types of things. Anytime you're designing a building and implementing, you want to have redundancies in the building envelope, especially in terms of moisture. So, for example, you want to have head flashing over a window that has flanges or without flanges so that the water can drain that out. And you want to keep everything in shingle fashion, just like on this mock-up over here. Everything is shingled so that the water drains down. All those things, and then using a robust material. Self-adhered membranes are a redundancy. You don't need them, but if a hole gets in that and water goes back there, there's nowhere for it to run. It's going to drain out. It's going to have minimal damage compared to a mechanically attached system. So there's all these strategies, all these ways that we can improve our building envelopes. But the basic concept of rain screen is deflection, drainage, and drying. And then by using durable and healthy materials and ones that are easy to install, we're miles ahead. And again, adding in redundancy to the systems. So let's look at some examples of when this might not go well. This was a high-end residence on Lake Michigan, and it was a typical new build with white plastic stuff on the exterior and no rain screen system. And in this particular climate in Michigan and on the coast there, they get a lot of winds, a lot of wind-blown rain. They had black mold and issues to deal with very quickly after construction. I think they also lacked head flashing above a lot of the windows, and you can see there's quite a few windows on this. There's a case study of this on our website, but the bottom line is they took all this, it was a tongue and groove, like an Ipe type siding, I think, and actually that might be Cypress. Anyway, they took it off and then they added a drainage matrix back in with an all-in-one WRB, water-resistant barrier, air barrier system, and drainage matrix. And that solved the issues that they had with the drainage. And again, you can also see that they've got head flashing going in as well. So they're making two improvements that were critically missed, that had they had those during the new construction, it wouldn't have been an issue. This was a really fun project in Gig Harbor, Washington, where our offices are, our corporate headquarters. And it's actually my boss's church. They took the lap siding off of this 40-year-old building. It was in decent shape, but some of it had cupped because these big overhangs, again, another redundancy that's in a design detail, these overhangs that you see really protected the siding. But they decided to remove the siding, save it all, and then add in battens to give that drainage and the rain screen system. They upgraded the air barrier system, which it didn't have initially because it was a 40-year-old building. They added an air barrier system, as you see here, same membrane system as on this and on the mock-up back there, and those battens, and then reuse the existing siding. You can also do this with stucco and masonry, and this is showing that drainage back there. This is just a concept that we are still not seeing that frequently around here, unfortunately. And I'm going to show a few examples of why that's problematic, even on some buildings on this block. So here's a few project examples. So these are just a few observations I'm seeing around here. I'm not going to dwell on this very long, but one of the issues that I've seen in town is sometimes with these all-in-one systems where you just have taped or caulked sheething, those have, some of them have an integrated water resistant barrier, but the sheathing panels weigh about 110 pounds that have that, by the way, at least the gypsum ones. The wood ones, the green stuff that's out there by Huber is a little less, that's lighter because it's just an OSB, but it's a very thin coating. And so here's some examples of some projects. This is actually an open joint rain screen where they just put dense glass up and then they put a sealant over the joints and called it good. And then they painted it black, I believe, with spray paint so that you couldn't see it back there. I don't know how well this building is doing, but another thing I want to point out is you've got a reverse lap of tape over the windowsills there. And these are common defects that I see around Chattanooga area. And here is a perforated building wrap that should not meet code. It inherently leaks and it inherently traps moisture behind it. It's a vapor barrier at every square. And then the only reason it allows any drying is because of air movement through those little pinholes that you see everywhere. And you can see what staples do to it. And these kinds of membranes are all over buildings around here. Also, mixing different systems is very problematic. As you can see here, it can get really sloppy. I think this is actually Texas, so we're not the only ones doing it. If you don't put a rain screen in behind stucco on a masonry building, oftentimes if it's not maintained well, you'll see that it will make its own eventually. Window detailing is very important. And as you can see here, cutting an X and folding it in is a great way to funnel water into your building. All right. But it's not shingled like this. And you'll see this a lot if you drive around, especially with mid-rise wood frame construction, because one of the issues with mid-rise wood frame construction is you have a lot of residential contractors that aren't used to the liabilities involved in commercial construction, and they're using the same sorts of techniques and not used to following architectural detailing and just building a kind of a big house out of wood. And there's a lot of challenges with that. And the same materials that you just grab off the shelf may not be compatible with what's specified. This is on this block here. And this building has some significant issues. If you see all this water, these panel systems back here have no drainage behind it. Any drainage is purely incidental. And look at the water resistant area and look at the dark stuff back there is mold already growing before the building was finished. So these are issues that are a pretty big deal that are really unfortunate, but that can be avoided. This is a close-up of what some of the painted OSB that's out there looks like after just a few months of exposure. You can see all the micro perforations out there that occur. So you just want to be really cautious. This is a building in Minnesota that ended up having a lot of complex geometry that had a lot of leaks because they tilted their walls in and didn't treat it like a roof, like it needed to be, didn't consider things the right way. This is another example of just taping the joints. This is not too far away from here either. And this is just taping the joints on dense glass, and then they went right up over it with the masonry, with the brick. There's no water resistant barrier in this. This should not meet code. And we're going to be talking about this. Another example of that, not too far from here as well. You can see the masonry going up. This is not a water resistant barrier. It's just taped or caulked seams on gypsum, and that doesn't meet code. A lot of challenges. Here's another example. This is in Nashville. This is using residential materials on a multifamily mixed-use building. And you can see the window details. They look okay, looks fairly tidy, but you see this is a home wrap. That should be an indicator right off the bat there. But that tape on the exterior is also a red flag because that will deteriorate over time and water will get into all of those window sills and window heads. Here's another example. This is actually up in New England. I saw recently, and this is a passive house certified project. They're attempting that. I don't know how they're going to achieve it by cutting X's with this imported European membrane and these reverse flaps of tape. So we're not the only ones that are seeing these types of things. This is in Denver, Colorado, where there's just tons of development happening. You can see just miles and miles of these mid-rise wood frame construction. Very challenging. One of the flaws that I often see too is brick going up maybe 2 or 3 stories to a windowsill. All right, that's a real common, really typical architectural detail. And what happens with wood over time when you build a building? What does it do as far as does it settle or does it grow? Does it go taller or does it grow less? It settles, right? What happens with masonry? It does the opposite, it grows. So if you have a masonry exterior and you terminate it at a sill, that sill that was sloped after a couple years is sloping the opposite direction. Very common flaw that you'll see. And it's just a simple architectural detail, but from not understanding the material science. This is an example in Boulder, Colorado, of a 2-year-old building that's already got stucco issues because they didn't put drainage behind there. High-end condominiums, look at the cracking and moisture around the windows. So we're not the only ones, but we can do a lot better than this. This one has multiple different sheathings together. So it's got a system, but it's not a system because it's mixed with all kinds of different things. And OSB, so here's an example. You can see some fire-treated plywood, some non-treated, some coated OSB, and then some untreated areas with just perforated building wrap. We can do a lot better than this. This one looks tidy from the street, but it's got a vertical water-resistant barrier on a horizontal ledge there. And it's not an air barrier system, and it's got multiple different tapes around the windows that may or may not be compatible. And so just a lot of things to consider. And every single one of those has a reverse lap at the head. And so these are all kinds of issues that I think the building inspectors, are any building inspectors in here? Bummer. There's one building inspector right here who tagged this wall. We need a lot more of that going on around here to highlight some of these things, but it goes on and on. So here's a building just right over there that you can see. This one has 4 different water resistant barriers on it that aren't very water resistant and aren't very durable. And they went ahead and started putting the cladding on it right over the top. And I think Edward Munch was very appropriate and might have had this in mind when might have had Chattanooga in mind. But you can see right here, this is mold growing on before this building was completed as well, which is right over there on that sheathing. And I think we can do better than this. So I just cautionary tale, a little octone, but I think we can do better. So, all right, again, we're not the only ones that do this. This is, anyone want to take a guess where this is? Good. Castro is my hint.
Cuba?
Yeah, it's in Cuba. So this is, has anybody been to Cuba here? It's the capital. So when you're in the capital, did you walk around the main square in the capital at all? Okay. When you're in that main square, it's pristine, it's beautiful. And it only takes about 1 or 2 blocks before you get into this everywhere. And it's just building, it's almost scary walking the streets. It happens to look really cool. I love the patina, but it's really problematic for moisture management and durability. And it's actually a life safety issue. You've got what we call de facto green roofs or unintentional green roofs. They didn't get any lead points for any of this down there, just so you know. And I believe this building doesn't have a roof anymore either. So it has a self-watering type of a system going on these balconies. Ingenious, but very problematic for life safety. So let's talk about historic preservation just briefly here, because there's different ways that we can deal with this that relate to the deep energy retrofits. We can do overcladding, recladding, and we can also have various forms of restoration and restorative repair work as well sometimes. And there's different strategies for how we will look at this. And adaptive reuse may be involved as well, like this building here and others around town. There's a lot of great examples of that. Check out Krog Street Market and Ponce Market in Atlanta are great examples of that as well. And then there's a new mass timber building adjoining to the Ponce Market. So here's an example of an antebellum single-family residential row home in Cincinnati where they put battens back there, right? That's a good thing. They put rain screen in. Very cost-effective way of doing it, but they missed an opportunity to do an air sealing and a water-resistant barrier back there. And actually, because they missed that, the family that owned this home had to move out because they didn't address the lead paint that was residual on the cladding there. So it was in great shape, but they actually, by putting that cavity in, although it had great consequences and help for both energy and for moisture management, they failed to take into account the lead paint issues and some of the other things. So you have to look at it a little bit more holistically. This is another overclad example that you may be familiar with, or may or may not have noticed, but they're slowly going through this as the federal government decides they want to use our taxes for this purpose. Here we have they're going over the existing GFRC. So this building is actually, there's masonry sections, and then there's GFRC direct to studs, which is kind of like the commercial version of T111, if you guys remember that. So they basically waited until the very last minute of that GFRC before it starts to crumble, and they're going over it with a self-adhered air and water barrier system, and then putting an ACM cladding over the top of it and painting it to look exactly like the original GFRC. So one overclad strategy. One of the things I want to point out here that they did is they have horizontal cladding attachments, and they did put shims behind those. And this was actually J.W. McDougall Company out of Nashville, the largest metal fabricator in the country, I believe. And they did like the Epcot Center is their famous job. A lot of big projects, union shop out of there. But also another thing is they would have been a lot better off removing the fenestration. It's very difficult to do a good incorporated overclad or reclad without removing windows. This is an example of when they did remove windows, and this was Surface. Is that right? I can't remember. I think it was Surface Architecture. Anyway, this is the La Paz Center, and it was similar to this, a masonry building, not brick, but CMU. This was a fire station, where a separate building from the main one, and it's adaptive reuse where they've turned it into Hispanic culture and social services building and ministry, and it's a really neat project. What they did is they added an air and water barrier system over it that's UV stable, and then put a really clean, modern, open joint rain screen over the exterior. Very cool project. This is one that will probably before too long be a reclad. It's not yet, but a lot of the buildings that were really ugly earlier that I showed are behind this. So you have an opportunity when you reclad to improve things. You can get it back down to the sheathing like this. This is new sheathing on this building in downtown Nashville, and then you can overclad it. So 5th and Broadway are right next to that. So you can look at when it's a historic building or something that you want to preserve, you can look at prioritizing the interior or the exterior. And sometimes you can do both, but more often than not, you're going to have to choose one or the other. And there's disadvantages and advantages for each one. When you prioritize the interior heritage of a building, like let's say it's an art museum, and then you can have a lot of opportunity to improve the performance of it by adding insulation to the exterior. It's a lot easier to do that than to do it to the interior. And from a building science perspective, it has better results, generally speaking, in most climates. The exception being like a hot, humid climate in Florida. But even there, as long as you are not restricting drying potential, it's going to do well. If you prioritize the exterior, so you have your public heritage on the exterior, then you are a little bit more limited, and you're probably going to have more maintenance costs because the exteriors are going to continue to add to the, it's going to be wet, it's going to have weather to it. This is an example of a building that prioritized both to some degree. But as you can see here, there was a major HVAC. This building relies a lot on the HVAC to accommodate both the humidity levels, the latent load, and also the heat. And there's a lot of the heat in the wintertime. It really pumps out a lot, as you can see. We're warm in here, but it's active most of the time because there's a lot of energy loss on the walls because of prioritizing the interior. Some are very obvious. Here's some examples. This is a church that a friend of mine actually pastors up in upstate New York, who is built in 1803 originally, and it's right on the Appalachian Trail. He has about 300 hikers come through his home. He has a little hostel every year. It's really pretty cool. And then this is the public square in Peru. Pretty obvious exterior preservation there going on. I love these old barns that are reused and relocated. The old mortise and tenon joinery and timber framing. This is the oldest pub and restaurant in the US. It's actually, interestingly enough, called the White Horse Inn, and it's in Newport, Rhode Island. It was built in the late 1600s, and I believe most of the building is original. And then if any of you have been to the tea houses up in the mountains, up in Banff and Lake Louise area, that's what those are beautiful examples of both interior and exterior. They're over 100 years old and very well preserved. Sometimes we're taking, not going to dwell on adaptive reuse. I think you guys all know what that is. Here's an example of this was actually a Roman Catholic seminary that was converted into a Jobs Corps center up in Pennsylvania. No, this is in it's right on the edge of Pennsylvania and New Jersey, of the Delaware there. This is a UMass Amherst mixing an existing multi-wide building like this with mass timber and mass timber hybrid. So it has post and beam that's wood, and it also has HSS. Here's one of the coolest adaptive reuse I've seen. This is in New Haven, Connecticut, because it has this really amazing street mural that tells the story of the neighborhood there. And they added 2.5 stories essentially of CLT on top of a 1860s, 1870s brick building, if I remember correctly. Jeff Spiritos is the developer there. He's a real pioneer. Gray Oganchi Architects right next door. They dropped an elevator, a pre-made elevator shaft down, which is really cool, and it sort of anchors the entire building. Really cool project. This is up in Cincinnati, some of the Art Deco. But so, you want to take a look at what kind of deferred maintenance has been involved, but bulk water management is always number one. Anytime you're doing this, you can do all the insulation and energy upgrades you want, but unless you're addressing the way that the water is in these buildings, you've got to take that into account. So due diligence, really spending a lot of time in your CDs, especially, and the detailing, understanding basic building science, working with a good team. Just a couple other examples there, interior and exterior. That's the Carpenters Union Hall in Philadelphia. This was a Episcopal church in Ithaca, New York, and beautiful exterior detailing. Not always obvious here. Here's an example of a home on Signal Mountain that I think was either, I can't remember if that was eaves or stucco, but that one, again, no drainage back there. Anytime you have a cladding that's absorptive, then it's all the more important to have that drainage behind it. So brick, fiber cement, stucco, those are all absorptive claddings. So, and then here's the Capitol in Cuba. And then just coming off of that, you can see there, you've got the buildings deteriorating. So a lot of fun different buildings. This is a living building challenge pursued. Treehouse hotels over here. There was a lot of fun participating in. You see the reused cladding there. This is a pretty amazing adaptive reuse project in St. Louis called City Museum. If you haven't heard of that, look it up. The bus hanging off the roof is one of the coolest details. Here's that elevator shaft in that building in New Haven, Connecticut, and the detailing on that building right there. But let's learn from our past and the mistakes that we've made, whether it be from marketing or from just not understanding building science. We know how to build with rain screens. We know how to protect buildings with good detailing. There's no substitute for good craftsmanship. The stuff that y'all have learned at Build It Green is very, very valuable. And I hope that you'll have the opportunity to teach others. And whether you learn this word or not in the process, you're helping things to be hydrothermally more sustainable and by building well and incorporating rain screens. So if you have any questions, go for it. I'm going to skip through a few slides and talk briefly on roofing also. And also just a few examples of some good projects locally and some things that are coming up. If you want to learn more about Rain Screen, the Rain Screen Association in North America is a great resource. And I've been a member of that since the beginning. It's been a lot of fun. And we can avoid these types of unintended drainage, so to speak, in buildings. This is actually up on Signal Mountain right here on the right, example of that. This is down in Patagonia in southern Chile, actually a government building. You can see this was an involuntary reclad. And then you can see the mold growing behind the paint because of poor window detailing on that very same window, or that one on the right there. And so these are all things that can be avoided. And again, not using these cheap pulling things off the road. So let's look at a few examples of how we can do things well, how we can do things right, how we can avoid a building falling over like in Cuba, and maybe have some beautiful landscaping and incorporating that patina as well. So this is that White Horse Tavern. One of the things that's interesting about this building is the window detailing is designed to shed moisture. So remember how I talked about that craftsmanship. Sometimes it's in the architectural details, sometimes it's not. But the old cornices are also designed to shed water. They're designed, you look at the rounding there, designed to drain that off and not pool on there. There are more noble adaptive reuse scenarios than others. This is one of the most. And remember that story about the lead paint, keep that in mind. And this is that GFRC, by the way, right before it was covered up on the TVA building down the road. And we tested the cladding attachment systems to make sure that they were going to hold out moisture as well. The other thing to keep in mind is when you're air sealing, the most common leaks are roof to wall. And then where's another really common leak, when you're air sealing, whether it be new construction or existing, where's another air leakage path? Windows are probably number 3. And then number 2, any guesses? Yes, wall to foundation. Wall to foundation is the other one that's very often missed. And so any theoretical section view, even compound section view, if you can think about it that way, has to be able to have a continuous line drawn around it for the air barrier system to work effectively. All right. Here's an example of a very successful project locally. You guys recognize this building? HKS Architects out of, I recognize it for multiple reasons. It had 2 layers of our membrane system on it. It had continuous exterior insulation, and it was very successful. So it had these redundancies, had good energy, had a lot of complex detailing, a lot of different claddings. I enjoyed poking fun at this architect because a lot of them are good friends of mine by how many different claddings and textures they used on their building. In fact, I think I have a section or a photo of that. But this building, of course, is a little bit special to me because it chased me around with my work, even while this was the view of that building while this was going on for me and my wife. So sometimes work can never leave you, but it was fun to have that at the same time going on here at the hospital. So this shows some of the complexity of the assembly, but the exterior insulation. And then it's getting because it had an open joint rain screen, then it had a second layer over that insulation as well. You can't really do that with mineral wool, but with a rigid foam insulation, you can put a second self-adhered layer over it. And that's what that black membrane is. That's called our reveal shield. And here's the cladding going up there. That cladding is not only different colors, but it's different textures. I think it's tectum. Pardon me. What was it? I can't remember right now. Maybe someone else remembers. But you can see some of the complex detailing there. One of the reasons this one was so successful, this project, is because of the mock-up. Mock-ups are a fantastic way, whether it be a residential, a multifamily, single family, mixed use, commercial. Mock-ups are a great way to work out detailing. And then mock-ups should also have the actual conditions on the building, just like this has here. It was a fantastic mock-up. They really invested in it and it really paid off. Unfortunately, we ended up back in this building under different circumstances than I was hoping for, but it's a beautiful building on the interior nonetheless. Here is that architect. So I usually take their logo just off the screen when I'm presenting to them, but you can see there that there are about 14 different claddings on this particular building, and this one happens to be in Memphis University Hospital there, University of Tennessee. Same architect. They do a lot of hospitals. It's a lot of fun. Don't worry, we got it dialed. You can use as many different claddings as you want. Just make sure that you think about the interfaces. And when you do that, use one air and water barrier system over the whole thing. Don't try to patchwork it together like you saw in some of the images before. And then having those dual layers, as long as it's permeable, as long as it's vapor open, you can do that type of system as well, like on the hospital here. Here was one of the first major branch technologies project here, just over on 20th. The bank, the Tennessee Valley Federal Credit Union, and a 3D printed facade is an example of exterior insulation and an open joint rain screen as well, with a UV stable Again, also incorporating a rain screen system. So examples, one of the things that we're getting into with CLT, and I wanted to spend more time on CLT because probably my mass timber is one of the most rapid growing sectors. But a lot of these buildings are being built and replacing concrete, which is fantastic, but it's more moisture sensitive. So you have to protect the floors as you go on. And I just want to note that for any of you that are considering that type of building, this is an example of what that looks like on that adaptive reuse project in New Haven. This is up at Amherst again, and you can see how well protected this. This is actually black spruce, I think, out of Canada, and you know, it's very nice that it can hold up to all the job site abuse. And then here's a local project. I don't think Christian ended up making it here. But this is his project up on Signal Mountain. But Rob, I thought I saw him here earlier. Anyway, this is a great example of mass timber, old mass timber that's being done really well to protect it during construction. This is the interior. They took the roof off and they used this system, this roofing underlayment that's permeable to protect it during construction. And it was exposed for about probably over a year. Yes, thank you. We are getting the time. And a lot of really great detail. You can see the pooled water on the top, and then they built this house around and over this. There you are, Dylan.
You say that material is permeable?
Exactly.
How is it protecting and keeping water up there, but yet it's permeable?
The same way Gore-Tex does. So just like how Gore-Tex keeps out water and air and allows the moisture vapor to escape, that's how it works. It's the same kind of technology. It's just we're incorporating that in buildings now. And it took us about 5 or 6 years to develop the technology to incorporate that into roofing. And so in roofing, just like walls, you have the different control layers. You have your moisture loading, you have your energy flow, and then you have your airflow, which is both energy and moisture. Oops, I didn't do that, but anyway. And here's some examples of some projects that incorporated this permeable air barrier system. This is the Texas State Capitol right here in Austin. And this was built in around 1885, I think, or 88. And it's only had 2 roofs on it, right? It's 20-ounce copper. It's pretty durable. And so they thought, well, we'll just go with original underlayment as well, which is felt paper, building paper. It took a long time, but we convinced them that we've made some improvements since then, especially since they didn't have to tent the building and protect it separately. And so with this, you can also use it as a temporary water barrier. So not all period appropriate materials are appropriate for the way that we build today. So there's a lot of improvements, just like in the air and water barrier and the walls, that we can do, that we've made in the roofing as well. And being able to have self-adhered is the real trick and have durability along with permeability is the biggest challenge. So I've pretty much got to wrap it up here. And I think my computer might be stuck anyway. But does anybody have any questions? Yes, please. Handful of what? Yeah. Everybody is. It's just some people can tolerate it a little bit more than others. Yes. Yeah. Even materials that are treated with antifungals and antimicrobials, because of dust and dirt that builds up on them, they still are susceptible to growth. And so you're going to have growth no matter what. The best approach that is generally understood to preventing mold and mildew is air sealing, good air sealing, and moisture management, in that reverse order. But they work very closely together because moisture vapor rides the superhighway of air leaks. and then also mold spores and other things. And so when you control the air, but you let things dry out through permeable materials, and then control the bulk water so it's not working its way around those things, and for example, window head flashing detailing, then that's the best way to manage that. When it's, and especially during construction, that's another time to pay attention to that, especially with wood buildings. So that's where you're going to find it's not really low hanging fruit, but there's no substitute for good materials, good craftsmanship, and good design.
The critical factor for both like
Yeah, and you can only really do that effectively with a good air barrier system. Yeah, for sure. Yeah, any other questions? I'm gonna just cycle through the rest of these slides while I'm talking, or while, if you guys have any other, but this was a little bit of a this presentation. I threw in some images and some content that I'm going to be developing into another presentation. This is at Swarthmore College, by the way, up in there was a retrofit and reclad and re-roof in some areas. This went back. But anyway, this I do want to say this one last case study. One of the great things about having perfect permeable underlayments now that are self-adhered and that are protect from water is we can actually save a lot of materials that we couldn't otherwise. So with this, the Tampa Airport Terminal F project, they were doing a re-roof with Merchant and Evans with this standing seam barrel roof. And they reached out to us because they found out about our permeable self-adhered roofing underlayment that will protect the terminal while it's operating and allow that insulation to dry out, because nearly every time you take off an old roof, you're going to have wet insulation. And typically that just has to come out because you can't re-roof over wet insulation, especially with a low slope application. And so this allowed that to be protected and gave it time to diffuse that moisture out and saved a whole ton of polyiso from going to the landfill. And this is something that's new in the industry in roofing that has a ton of potential. It's something that we are really after right now. And just like the understanding with this retrofit at Bennington, just it's relatively new. There's a great study that is by Colin Murphy out of New Orleans called Self-Drying Roofs. And if anyone wants a copy of that, I'd be happy to. My time is up, and I will put up my contact info up here. Oops. So that you guys can, and if you're interested in more, also on our website, we have these right here that you can go to. That's right on this AI Live link. And here's these projects in Tennessee that I was going to show you, but that's it.